Channeling is a very big problem in blast furnace, and how other plants are encountered this channeling well before time, before getting furnace disturbed. This is one of the presentation from Kobe where the case of Kobe has been shown here, how they have come across the channeling problem solution. Before going to that aspect, first of all, channeling is a phenomena where hot flow gases unevenly through the raw material, that is the burden layer inside the blast furnace. It is caused by a ventilation failure where the flow of hot gases is obstructed, leading to a gradual increase in internal pressure. Causes can be summarized like one of the main culprit is excessive fines material being charged, improper distribution of raw material, high level of liquid iron and slag in the hearth, deterioration of raw material quality, and this all makes a lot of big reasons in the blast furnace in terms of unstable blast furnace operation and reduced production, increased heat load on the furnace wall, potentially damaging equipment. In worst case scenario, it can lead to an abnormal shutdown of the furnace, impacting the entire steel works. Now we are going to see the what sort of approach is there to tackle the channeling. The CSC visualization and RMSD method, a system based on 3D visualization and real-time pressure monitoring. Now let us discuss its core technology. This system developed for the China Steel Corporation, number 2BF. This uses general regression neural network GRNN algorithm to create a 3D visual model of real-time pressure changes inside the furnace. Now we will see what is the key predictive indexes. The RMSD, that is the root mean square deviation of the shaft pressure, is used as a primary index to quantify abnormal pressure change. What is the prediction criteria? A channeling alarm is triggered based on the two specific conditions. One is RMSD of shaft pressure exceed 0.15 kg per centimeter square at the 7th level, and second, the annular gap element opening is greater than 60%. And what will be, this result into system provide a prediction 10 to 15 minutes before channeling occurs, giving operators enough time to adjust the furnace operation and prevent the event. The Kobe steel permeability index method, a multi-factor statistical approach to quantify channeling risk. The core concept behind this is the system calculate a permeability index by combining multiple feature quantities that are highly correlated with the channeling risk. It recognizes that channeling involve more than just pressure. It also linked to significant change in temperature distribution also. The index integrates 8 distinct factors: pressure fluctuation, analyzes variance over multiple time period and height, temperature uniformity, which measure the temperature distribution in both circumferential and vertical direction, track temperature in upper and mid furnace as well as furnace top gas, uh, capture the difference between high and top temperature part of the furnace, and monitor the pressure of hot air blown into the furnace. So it takes into consideration of various parameters. Now calculating the permeability index and combining these features, each feature quantity SC1 to SC8 is converted into a standardized index value from 0 to 1. This process expresses the degree of deviation from the normal state. A parameter alpha is used to define the threshold for a deviated state and can be adjusted based on operational data. The system tested three candidate indices: SCA, SCB, SCC. SCC was chosen as the most effective index because it's best suppressed over detection while still capturing all large scale channeling event. The SCC combines pressure fluctuation, that is SC1, temperature pattern of SC2 and SC3, and other temperature pressure indicator like SC4 and SC8 into a single robust value. A lowering instruction is issued when two conditions are met. What is those conditions? The first condition is the permeability index value exceed a set threshold, and second is the maximum pressure in the upper furnace exceed its threshold. So these two conditions uh, control the blowing condition, blow lowering condition action. Coming to the other interface of system implementation and user interface, how operator interact with the prediction system. This CSC live view system provide a real-time 3D visualization of BF shaft pressure updated every 10 seconds. Uses a simple cooler cool system to indicate furnace status like a green normal condition, yellow warning condition, red danger display. All those that is when red is there, there is a channeling risk is there. Now displaying a key metric like AGE opening and location of abnormal pressure change directly on the screen. Kobe Steel's parameter adjustment tool is to ensure long-term accuracy. A tool is developed automatically adjust the indexing parameter alpha when raw material characteristic or operating condition change. This removes the need for manual adjustment and helps to maintain the system predictive power. Coming to the performance and validation, the proven accuracy in real world operation CSC system is successfully installed in the CSC number 2 blast furnace. Test results confirm that the system provide a reliable 10 to 15-minute advance warning, which is sufficient time for operator to take corrective action. Kobe is still evaluated using 1.5 year of operational data not used for parameter setting. It is achieve over 90% accuracy, with remaining 10% being cases of severe furnace distress where channeling was imminent. Successfully predicted all large scale channeling events without any misses and is now utilized in actual operation to guide blow lowering decisions. So the future of blast furnace operation is data driven now, as we have seen in terms of controlling the furnace operation, in terms of the severe channeling. The problem, though if the problem is complex, but it also rely on human judgment. No, alone for channeling prediction is insufficient due to complexity of blast furnace operation and risk of operator inexperiences. Two effective data-driven solutions is we have seen visualization method, that is CSC, which is excellent for real-time monitoring through an intuitive visual interface based on the RMSD and valve opening AGE. Permeability index method is being seen. We have seen in Kobe Steel, which provide a robust quantitative risk score by integrating a wide range of pressure and temperature data. Now let us review those key benefits. The key benefits are early prediction. Both systems provide the critical advance warning, as we have already discussed, before the channeling occur, and it increases the stability and safety. It enables the operator to take a proactive measure, preventing production losses and equipment damages. And decision making also becomes more precise by going through these. So all these are the basically benefits that we have got from this incorporating both ideas at Kobe and other on RMSD, that is permeability index and RMSD.